In this video, I will be explaining about wrapper classes, what are wrapper classes, and also we will discuss in detail about one of the class, that is integer. It is a wrapper class. See, in Java, we have primitive data types like int, float, double, char, all these are primitive data type. Here I have one example, that is integer I assigned 10. I have taken an integer type variable. See here, I is a variable of type int and int is a primitive data type. But we know very well that Java is a object-oriented programming language. Object-oriented programming language. So in Java, everything should be an object. And for that, there must be some class. If everything is an object, then we can say Java is a pure object-oriented programming language. But here, primitives are not objects. These are not objects. These are primitives. How these primitives are different? See, if I is a variable of type int, then I should get some methods. See, in every class, there will be some set of properties and methods, and we can usually access methods. So using dot operator. So over this I also, I should be able to access its method by pressing dot. I don't have anything inside I. So I is not an object. It is just a normal variable. So we say primitive type of variable. So primitive means built-in data types, right? Primitive means the built-in inhabitants of compiler. So it's a primitive type. All right. Now, for primitives also, we want classes so that we can treat Java as a pure object-oriented language. So that's what Java has provided wrapper classes. It has provided wrapper classes. So it provides a wrapper around the primitives so that the primitives becomes classes and we can create objects. So we will look at these wrapper classes. So for every data type, wrapper classes are available. See, wrapper classes are available for character type data, byte type, short, int, long, float, double, and boolean. For all these data types, the wrapper classes are available. I will show you these wrapper classes. All these classes are present inside java.lang package. They are present in java.lang. So let us visit java.lang package. See, this is java.lang package. Inside this, I have a class for byte, boolean. See, these are the classes, boolean and byte. And for character also classes there. Like that, double class is there. Okay. And for float classes available, this one is a float. And integer, long. And there is a class called number. There is a class called number. I will come to it. Let us look at other classes. Short is also a class. Okay. So void is also a class. So these are the classes available. Now I will take you to integer class. See, this integer class is a child class of number. Child class of number. So number is a parent class for child. Likewise, integer, there are other numeric classes that are number related classes that are inheriting from number class. So I will show you a chart that is hierarchy of classes. See, here this is a number class, and from that these classes are inheriting byte, short, integer, long, float, double. And character or boolean are not numbers, so they are not inheriting from number. But number, character, boolean, all these three are inheriting from object. See, usually we show object on the top because object is a parent class for all Java classes. So we say that they are related to parent, that is object. So number is one of the class and all these are child classes. Let us look at the methods of a number class. See, these are the methods of a number class. A number class is having methods like byte value, double value, float value, int, long, short value. So for it means any type of a number can be converted into another type. Like if you have a float, it can be converted into a byte, or byte can be converted into a float, or double can be converted into int. So this all these methods are abstract. You can see that these methods are abstract because these methods are implemented within those classes. How the conversion should be done, how to convert a float into double and all, so that will be done by the class itself. So all those methods are present here inside the number class. So they are available in these classes also, and each class will override that method by its own way, because this byte class knows how to convert into a float, or float class knows how to convert it into a byte. So they override all those methods. So one thing is sure, that those methods are present in all these classes. This is one common thing found in all these classes. So let us learn how to use these classes. So I will show you how to create the objects of these classes and how to use them. So I will give the example for all of them. Now the first, I will create integer I assign new integer, and the value is 10. So it will create an object of integer type whose value is 10. This is one of the method by creating an object of an integer class. See, I is a reference of an integer class and integer is a constructor. So we are creating an object. And this method of using a constructor is now deprecated. We should not use the constructor. There is another method. So I will create one more variable of type integer, a assign. I can use this integer dot value of, I can mention some value. Let us say 10. This is the proper method. So this method of creating an object is not suggested now. So better follow this method. But here I am getting a underline here. So it is saying that unnecessary boxing to integer. So what does it mean? I will show it afterwards. But ignore that now. Now one more method is integer b assign 10. I can directly assign the value also. Right now this is a proper method. Alright. So integer b assign 10, directly you can use this. Now let us create the object of other classes. Byte C. I will be following alphabets A, B, C, D. Okay. Instead of giving a lengthy variable name, I will use alphabets. So I can assign a value 15. Directly I can assign a value. Now I will show you one more method of creating any of these objects. Like I can do it for integer also. Now I will show it on byte. Byte dot value of, I will give a string 15. So this will create an object of type byte by converting this string into a number. So I can give a numeric value also, and even I can give a string also. Now one more method is there. I will show you that method. Let us check what happens. I will create an object byte value of. Now second method I am using, that is value of byte. So it returns a byte. So it will take a byte type of value. So I will give the byte value as 15. Oh, it is giving an error. It is giving an error. So directly I cannot use this because this is not a byte value. This is an integer literal. This is the integer literal. So for this, I should create a variable byte. Okay, bb assign 15. Then that bb I can give here. So I should give a variable of type byte. Then it works. So for creating a byte, I have directly assigned the value. That is allowed. I can give it in a string form. And for a byte type of variable, I must already declare a byte type of variable, then I can give it when you are using value of. Now similarly for short, f assign short dot value of, I will use a string 123. So this is short. Okay. Same thing applies. Whatever we learned just now in byte, same thing applies on short also. Now let us create a variable of type float. Float G assign 12.3. Oh, it is giving error. Why it is giving error? Because this 12.3 is not a float constant, it is a double constant. So I should mention it as a float constant by writing F. Then float H assign float dot value of. Can I give a string here? 123.5. Yes, I can give a string here. So a decimal number, right? Floating point number, it will create an object of float. So I can directly assign the value, as well as I can use a value of method. See, when I am directly assigning the value also, it means usage of value of method only. Like here, writing direct integer value 10 or saying integer dot value of, it means the same thing. So internally, when you assign this b assign 10, so internally it will call this method integer dot value of. Let us go ahead. I will create an object of double, I assign double, and I will give some value, that is value of, I'll give a double value 123.456. It's giving an error. Oh, I have redeclared I, so I will declare j. In the beginning I have declared I, so take another variable j. So this is a double. Now for a character, k assign character dot value of a. No, for a character I should mention it in single quotes because it's a character. So for all other we can mention it as in a string, but for character we have to use single quotes. The next is boolean L assign boolean dot value of true. Yes, it accepts. So this is how we can create the objects of these wrapper classes. All these are wrapper classes. Now let us understand the term wrapper. What does it mean by wrapper? See here in this example, I will take out this example. I will show it separately. Okay, here I will write down. See, bb is a byte type of variable, and then e is an object, reference to an object of type byte. So around bb, it will create it as an object. So it is just like, I will show it as a diagram. Variable bb is 15, right? Then e is an object which contains bb. So it is making like a box. It is making it like a box. So this bb is kept inside an object, and object is just like a box. So e is a reference to an object. See here we have e is a reference to an object, and bb is a byte type of variable. So we call this process as boxing. So we call this process as boxing or wrapping. So it is wrapping around this primitive variable, that is bb, and making it as an object where a is a reference to that object. So in that sense, this is a wrapper class. So wrapper around a primitive, so that primitive becomes a object. So we can call it as wrapping as well as boxing. Now I will show you one more thing. I will take a float type of primitive x, and to that this float value I will assign. So what is the object name? H, right? H dot float value. So H is a float type of object, right? Float type of object. From that we get the float value, and it is assigned to x. Now I will show one more important thing. Y assign H dot, just H semicolon. I can even directly assign H also. Yes. So what is H? H is a float type of object. This one, I will copy it from there to move it here. Now look at this one. Now just look at these three lines. See here, I am creating an object of float by using a method value of, right? So it will convert this string into a float type of value. Then that object, I am calling a method float value. I am getting a primitive. So this float x is a primitive. So from this object h, I will get a primitive value. So here it is called as unboxing. From an object, we are getting a primitive out of that object. Now, next line is very interesting. Here I am writing just h. So it will automatically call dot float value. Automatically it will call, and it will store it in primitive. So these two lines are same, but in this line I am calling a method float value. In the second line, automatically this method will be called. So this is called as auto unboxing. Auto unboxing, right? So I will tell about auto boxing as well as auto unboxing. Both I will tell by taking an integer example. So separately I will take integer m, assign value 10. This is a primitive. Now I will take a object of type integer n, assign m. See, a primitive is converted into an object. This is called as auto boxing. Actually, I should write like this: integer dot value of, and in that I should write m. This is the method. So this is boxing because I am calling a method value of and converting this m into n. So I am putting a wrapper around m. So diagrammatically I will show you. See, this is m having value 10. To that I am putting a wrapper around it. So I am calling it as a box. So this is called as boxing. Right? Now same thing, I can do it by just writing m here. So automatically it will call integer dot value of. So this is auto boxing. This is auto boxing. Now next I will take one more variable, integer p. This is primitive. To that I will assign n. But what is n? N is an object. So object is converted into a primitive. So we get a primitive out of this n. So this is called as auto unboxing. Actually, I should call it like this: integer dot, that is n dot, into value. I should call this method. But instead of calling that method, I can directly assign it. So if I am calling this method int value, then it is unboxing, getting a primitive from an object. So diagrammatically, if you see, we have p here. To this value is assigned. So this is unboxing. So from a object, we are getting a primitive back again. So this is unboxing. And for that, I should say int value. But if I directly write just n, it will do the same thing. So it will automatically call int value. So this is called as auto unboxing. So once again, a primitive is assigned to an object. It is auto boxing. Object is assigned to a primitive. It is auto unboxing. So that's all. I have explained you about wrapper classes and how to use them. I have shown all of the classes here. All right. So you also explore them. This topic requires exploration. That's all, because these are the things that we use in applications. So practicing this topic means exploring the topic. So you to explore it, what all I have shown you, you try to do it by yourself. So that's all in this video.